Welcome back, grade 11s, and we're still looking at Newton's laws, specifically the application of Newton's second law. We are given a problem here. We are told that we have a tow truck that pulls a car along a gravel road, and the force applied to the engine of the tow truck is 90 newtons. The mass of the tow truck is 1,300 kgs, and the mass of the car is 950 kgs. And the vehicles are connected to each other by an elastic bar of negligible mass. So we can just ignore the mass of that tow bar. So we're also told that the tow truck and the car move at a constant velocity, and it's in bold, meaning that this is something that you should definitely note. So remember, when I was explaining these laws, one of the things that I said you should remember is when we're told that an object is moving at a constant velocity, it means that the acceleration of that object is equals to 0. And it is important it's important that when it comes to such situations that you identify the forces that are acting on the object or on the objects, right? And you can draw your force diagram. This is your paper, so be free to do whatever. So you can draw the force diagram in each of these objects. So we can draw the gravitational force, and you can draw the normal force, tension. This is how it is, and same thing here. This is Fg, this is N, obviously this is N1, N2, and the applied force. And remember that the frictional force, that's what's happening, because frictional force always acts opposite to the motion of the object. And same thing with this one, is that the frictional force is in that direction, right? So this is my force diagram. So you can see that I'm not looking at the problem. I'm not looking at the problems, the questions that we're given. I'm just literally analyzing the problem as it is with the information that I have. And let me just write down my data. The mass of the object of the tow truck on the side, but it's easier for me to work with. I don't have to always come back and read. No, I can just write down my data, all the information that I need, just on the side. So these are things that we have to note. So we can immediately now just jump straight into the questions. So it says, name and state the law that explains why the force exerted by the tow truck on the car is the same as the force exerted on the tow truck, right? So let me just, so it says name and state, and it's just like explain why the force exerted by the tow truck is the same as the force exerted. So immediately you can see that that is Newton's third law. Remember, I explained in the first video of the series is that if you have a person and there's call this person A, person B, right? This is the surface and this is the wall. This is not person B, this is the wall. If you are pushing against this wall, the wall will also push against you with the same force, right? So, and I told you that for you to know these definitions, you just have to memorize this from the examination guideline. And I did show you the examination guideline in the previous videos. So you just have to memorize, okay, what is Newton's third law? What is Newton's second law? What is Newton's first law? So what Newton's third law states that an object A exerts a force on object B, B will exert a force of equal magnitude on A. Simple, get your 3 marks and you're done. And let's get into, so 4.3, it says that we should draw a labeled free body diagram indicating all the forces acting on the tow truck. So in the beginning we drew the force diagram. So now we're told that we should draw a free body diagram. Right, so I'm just gonna remove all of this. All right, so we're told that we should draw a free body diagram. Remember, free body diagram, instead of representing the object as a block as we did here, we have to represent the object with just a dot. I'm drawing a big dot because I want to accommodate all my forces. So here's one force, a normal force, which acts perpendicular to the surface of the object. and the gravitational force which acts on all objects in the universe. The downward force, right, always pulls them down. And the tension is T1. Let's just call this T1 because although it's T, but then remember that there's also the pulling force, right, from the car. As this is the pulling force from the car, and then there is the pushing force from the tow truck, and then the frictional force, and then we have the applied force of 90. Let me just call this F applied, right? You can say it's just the 90, but since we're using labels, it's important to just remain consistent. And this is 5 marks, guys, and it makes sense because here 1, 2, 3, 4, 5, get your 4 marks. Right, so remember, a free body diagram is always represented with a dot, and you indicate all the forces that are acting on the object. And this is going to be very important when it comes to solving the other remaining problems. Now we're looking at the more numerical part of the problem that we were given. So we're told that the coefficient of kinetic friction between the tow truck tires and the road is 0.45. So calculate the magnitude of the tension in the tow truck. So let's first just write that down, 0.45, something that we should note. And so we are told that we have to calculate the tension. So firstly, remember what Newton's second law states, that the sum of forces acting on an object is equals to the mass times the acceleration of the object. And from the free body diagram, since we're looking at the tow truck, we can see that the forces that are affecting the motion of the object, it's just only the horizontal components, which is the applied force, the tension, and the frictional force. So what we can do is, firstly, let's choose the direction. We can take right as positive, and then let me just change that. So now we can say T1 plus, that's the tension, T1 plus Fk, you just put that in brackets, minus the applied force, since the applied is towards the left, is equals to MA, right? And what is Fk? What is the formula for Fk? Fk, the kinetic friction, is nu k times N. Remember I mentioned before that the normal force doesn't really have an equation. We have to derive our own equation based on the information that we are given. So from this particular case, the normal is equal to the gravitational force, because that's the only force that is acting in the horizontal. So normal is equal to Fg, which is equal to the mass of the tow truck times the gravitational force. All right, cool. So T1 can just take everything to the right hand side, but before, remember that the acceleration is 0 because the tow truck and the car are moving at a constant velocity. So this immediately falls off. So take everything to the right hand side. So Fk now, it's minus F applied. Sorry, it's negative plus F applied. And T1, let me just organize this properly. F applied minus mu k mtg. Nice. And T1 is equals to 9,000 minus 0.45, and the mass of the tow truck. What is the mass of the tow truck? Great. 1,300 times 9.8. This is always given in the formula sheet, the gravitational acceleration. So T1 is therefore equals to 3,269 Newton. To what? To the left. That's the tension force. Yeah. So you see that this don't really have to crack your head that much, especially when you've identified all the forces from the jump. If you didn't do this, if you didn't have your free body diagram, this was definitely going to be a very tricky situation, because you don't know what's happening. You don't know where T1 is acting. You don't know the frictional force and all of that. So remember, it's always important to draw the free body diagram or the force diagram and to just collect your information all in one place so that it's easier for you to just always, when you need to go back, you can just, plug and play. It just becomes quite easy for you guys. We expected to solve for the coefficient of kinetic friction between the car and the tires and the road. We've already found the tension in the tow bar, the magnitude of the tension in the tow bar. So from here, remember I mentioned that once you have your free body diagram, these problems become quite easy to solve. So, but we only drew the free body diagram for the tow truck. In this case, we can also draw a free body diagram for the car, and we can see that the tension, we can call this T2, which is the same, and it's Fg, and then there's the frictional force there. So this one is for the car. That's the free body diagram. So T1 is equals to T2, right? It's just that, but so we've already found T1, so T2 is equals to 3,269 newtons. Cool. So now we can still use Newton's second law, which is F net is equals to ma. I'm just gonna keep writing this down so that it's glued in to your skulls so that you don't forget. So since we're taking right as our positive, Fk minus T2 is equals to ma. And the reason why we're doing this is because we know the equation for Fk is mu k times n minus T2. And remember that this is 0 because acceleration is 0 due to the fact that it's moving at a constant velocity. So this is 0. And we're looking for the coefficient. So mu k is equals to T2 all over the normal. But what is the normal force in this case? So our N is equals to the mass of the car times the gravitational acceleration. So T is equals to mc, yes. And therefore, this is 3,269 all over the mass of the car, which is 950 times 9.8. So that's 3,269 all over 950 times 9.8. That's 0.3551. So it's 0.35. So that is the coefficient of the kinetic friction between the car tires and the road of the surface. So yeah, that's why I said that the free body diagram is a very powerful tool when it comes to solving these problems, because everything just becomes easier for you guys. So always remember that before you can even start, identify the forces acting on the object. I'm just going to keep on repeating this because some of you guys tend to forget that, and you just quickly just jump straight into the problem and you get stuck. You don't know what to do. So always start here, and then you can come to the more fascinating parts, but just do the work here first, and then everything just becomes easier. So let's continue with the last remaining problems. So this is more of a more abstract or theoretical, or maybe they just trying to see whether or not you understand these laws. So in this problem, they say suddenly the tow bar between the car and the tow truck disconnects and the car comes loose. Using a relevant law of motion, explain why the car continues moving forward for a short distance. So remember, always when they told you, they just gave you a hint. They said the relevant law of motion. So now you just have to, okay, is it first law, second law, third law? And it just says continues moving forward a short distance. So it's definitely not third law. It's definitely not second law. This is Newton's first law of motion. So 4.5, it's first Newton's first law of motion. I'm not gonna state it, but then this is just where the other marks fall in. So you just have to state the law. So just always examination guideline. Remember, you just have to state. So you guys are gonna state it because I've been stating it throughout the series. So let's go into 4.6. the last question. Calculate the acceleration of the car as it comes to a stop after a short distance. So now the tow truck and the car are disconnected, and so obviously they're not moving at a constant velocity. So F net is equals to ma, and so the only force that will act on the car is the frictional force. So when we go back to, this was the original free body diagram, so the new free body diagram now is N Fg, and there we go, Fk. So the tension is no longer there because they're disconnected. So now it's just going to be Fk is equals to ma, and remember that this is nu k times n, which is ma, and our nu k, we calculated it to be 0.35, and remember that this is the mass, which is 950 times 9.8, and it's 9.950 times the acceleration. So this cancels out. So our acceleration now is equals to 0.35 times 9.8, which equals to 3.44 meters per second squared. Yeah, this is it, guys. So please go back to the first video where I've explained Newton's first, second, and third law, and just go through this again and again until it's glued to your mind. But one of the most important things to note is always draw your free body diagram, or identify the forces that are acting on the objects when you're given such a problem, and just write your data on the side so that it's easier for you to work through the problems. And also something to always note, constant velocity, it means that the acceleration is 0. And always go to your exam guideline. I think I showed you. It has all the definitions and summary of the concepts. And yeah, this is basically it. If you ever get stuck, just always remember the things that I've mentioned, and you guys will definitely make it through. So tune in and see you in the next video.